Good morning, class. What do you say we have a lesson finally, after a couple of weeks of these, where we get to do some calculations, some computations. That is exactly what we've got today. So before you even start this assignment, do what I've done and pull up in a separate window. You can go File, New Window, or you can hit the little plus sign and then just drag that window out and set up a couple of different windows. One with a calculator. Again, I recommend just going to Desmos graphing calculator. You can Google that, or you could type in this desmos.com/calculator URL. It'll pull up. We're going to need it today. Today we're going to be doing some calculation. Yeah, you can use your phone for this as well, or if you happen to have a calculator at home, but I really recommend this Desmos calculator because it's going to be universal for everything we do, and it's just worth having up. Okay, once you have that pulled up, open up your assignment. Volume of prisms. You'll notice we have 8 problems. We have a little bit less than our normal 10. And we've been dealing with prisms the last couple weeks. You'll recall that the drawing of solids lesson, I grabbed a box that I'd received in the mail and broke it down and showed you what the two-dimensional net looked like. Well, there you go. That was a box. That was a rectangular prism. We also named it in a three-dimensional solids lesson. Today we're going to be literally calculating the volume. So a good way of memorizing or just remembering what volume is it simply how much can you fit inside of an object. Whereas surface area is how much you can fit around an object, volume is how much you can fit inside of it. So the common description or common anecdote that I've heard as a student and continue to say as a teacher is think about it in terms of giving a present for somebody. Surface area is how much wrapping paper you need to cover the outside of the box, and how much you can actually fit inside that box for the present is volume. In addition, volume is 3 dimensions. And so we are going to be seeing in each one of these a little 3 above our measurement for 3 dimensions. So if it's in meters, you're going to see meters cubed. If it's in centimeters, you'll see centimeters cubed. It's to stay that way for volume the whole time. Now, if we were in class, we have that gigantic formula sheet that I have up on my wall. We're not in class, but we have the internet where you're doing this from. And so I've always recommend that when you don't know a specific formula, you simply Google it. And when I Googled it, I found this awesome Khan Academy page. I love Khan Academy. This is very much a Khan Academy model, what I'm doing right now, filming lectures, uploading them, then you separately do the assignments. That's what Khan Academy has for anything. If you have some extra time, you're bored because you just finished both math assignments for the week pretty fast, I recommend logging on to Khan Academy. You can even start with arithmetic and just working your way through until you get stuck, and then you're guaranteed to keep learning if you keep going. There's videos like the ones I'm filming, though I'm not the one who's teaching in those. And then there's assignments like you have on Core Focus that are built into the website. You can do this with any math concept up through calculus. You can also do it for things like economics, science topics, and others. It's also the best way to study for the SAT, the ACT. So Khan Academy, learn it, create an account, and dive in sometime. All right, enough about Khan Academy. Let's just look at what they gave us for the volume formula. So it says for this rectangular prism, V equals L times W times H, where L is the length right here, W is the width up here, and height is the height of the box right here. Now, multiplication is what's called commutative, meaning 2 times 3 is the same as 3 times 2. This isn't true for every operation. Subtraction and division, for instance, are not true, but addition and multiplication are. Meaning, if you want to find the volume of a prism, very simply, you just multiply the 3 numbers together in any order that you wish. So I go to my Desmos calculator, and I could type 19 times 7 times 3, just using my numbers for number 1, and I get 399. And you'll notice if I did it in a separate order, like 3 times 7 times 19. I'd also get 399, and that would work for any possible combination of those three when multiplied together. And 399 is all we need. We do not need our units because they are already given for us over here. Always just the number. And guess what? Number 2 is the same kind of thing. We have a prism, so I could simply just multiply my 3 numbers on number 2. Again, use your numbers, not mine. If you use your numbers, you'll get it right. If you use my numbers, you're going to have to redo it because there are way, way too many combinations that you can get that I would be absolutely shocked if you got the exact same numbers as mine. I'd be pretty lucky if even one of the numbers was the same. If that's true, give me a shout out in a comment or send me an email. Let me know that coincidentally we had the same type of problem. All right, that's 1 and 2. It's pretty easy. Number 3 is an example of a net that has been given to you in the same way we had that drawing solids lesson that I referenced already earlier. We have a cube. We know it's a cube because every single side are squares, and they're 3 by 3 meter squares. So you could picture a Rubik's Cube that's been cut open and flattened. And we want to find the volume of it. Well, even though it's got all of these different squares, 6 to be exact, we don't need to do 6 different squares times each other, because when we fold it back up, it's still just a rectangular prism, meaning we got to multiply all 3 sides together. What's unique about a cube is that all 3 sides are the same. So I could type in 3 times 3 times 3, or also faster, I could just say whatever number you have. So if I have like 7 on the bottom, I type 7 instead of 3. Notice there's a button right here. That's your power button right there. So I could say to the 3rd power. So again, if all my sides on this problem, if you're staring at, are like 7, you would do 7 to the 3rd power, or 7 times 7 times 7. Why 3 of them? Well, not only is it the formula, but again, we're in 3 dimensions. So everything is going to be 3s. And as a proud triplet, 3 always has a special place in my heart. It's also the number of my favorite Portland Trailblazers player, C.J. McCollum. And I really hope that sports can get going soon. It's so weird to be home, but it's also so weird to be home when there are no sports going on. I know a lot of you out there like me are big fans of sports, whether it be basketball, football, baseball. Everything's pushed back. The Olympics are now delayed by at least a year. So let's hope that sports come back. All right, now we have a couple problems where let's read what we got. A pentagonal, remember our accent, sandbox has a base of 1.3 meters squared. The moment I see the squared, I know it's surface area, because that's always in square units. The sides of the sandbox are 0.2 meters high, meaning the height. It takes blank meters cubed of the sandbox to fill the box. All right, another thing about volume is that in general, the formula for volume of a three-dimensional object is the area of the base times the height. Now, if you had to manually find the area of a pentagonal sandbox, of that pentagon base, that would take some complex mathematics. That would take what's known as some trigonometry or some special angles sometimes to be able to work backwards, figure out your sides, then figure out the base. It takes a lot of work. You're going to break it into triangles and such. Fortunately for us, we don't have to do that because they just straight up gave us the area of the base already. And we could say, thank you, problem. You've made this so much easier. Because now all I have to do is multiply that 1.3, and not squared. Squared's just the units, so don't type squared, times our height. So now I have 2 numbers, and I'm just simply multiplying those 2 numbers together. Again, no squared, nothing else. Don't overthink this. Just multiply the 2 numbers together. Again, use your numbers, not my numbers. I'm going to say that so many times. Same thing for number 5. We now have a base area that they give us and a height. And thank God, because this, once again, is a hexagon. This would be really, really tough to figure out manually. We don't have to worry about that. So we have base area and height. So I'm going to simply multiply 115 by 15. And I get 1725. Now you can either use this multiplication symbol down here, or you could simply hit Shift 8. Shift 8 is it's like a asterisk button, but that also works for multiplication. All right. Number 6, pentagonal water glass with a height of 27 and a base area of 28 and 16 over 27 centimeters squared. Volume of the glass is blank centimeters cubed. It's the same thing. We've got two numbers. We're going to multiply them together. However, this is the first time that we're going to be utilizing the fraction key on here. So for that, I'm going to type my whole number, 28. And then I'm going to make a little space. And then I'm going to type 16. Now you can either use the division sign down here, or you can use the little slash next to the right shift key. Either way, it will open up just like that. And if you don't want to make a little space there, I'll show you. It's smart enough. Either way, you can even put in a bunch of spaces. It'll still say 772. And that's how you type that one in. It's so cool. If you're given the area of the base, you simply just have to multiply it times the height to get the volume of a prism. This isn't going to work for pyramids. This isn't going to work for cylinders. Only for prisms. That's why we're doing this first. It's the simplest and the fastest. Okay, number 7 is the first time that we have a different shape for our prism. Now, I'm going to draw something for you. I feel feels a little weird that we haven't had to use this yet. So let's do it now. Use this draw tool. And what I'm approximating, it's not perfect. All right. This is now what we've been seeing, our regular prism, our regular square rectangular prism that we've done on problems 1 through 3 especially. Now, you can see if I slice it Fruit Ninja style diagonally, whew, just like that, and get rid of the purple that I drew in, I'm going to end up with exactly half of my rectangular prism. Sure enough, that is our formula. If I go back to my helpful Khan Academy formula over here, triangular prism, which is what we have, is base times height times length, which again can be done in any order because multiplication is commutative, divided by 2. Or simply, again, area of the base times the height. Well, if we have a triangle as now our base side, we know that the area of a triangle is base times height divided by 2, because a triangle, in the same way that a triangular prism is half of a square prism, a triangle is half of a square or a rectangle that's been sliced diagonally. In other words, let's do what we did before, but then divide it all by 2. So I'm going to take my 3 numbers, 20 times 12 times 15. But then I'm going to divide it in half. Now watch this. This is kind of cool. So if I take all 3 of these and then divide it by 2, that is going to be the same thing as if I took half of, let's say instead of 20, I just halved that and did 10. And then multiplied that by my 2 numbers. In the same way, I could do 20 and then take half of one of this side. Say half of 12 is 6 times 15. And so I really enjoy these because you can just take your simplest number. Like for me, this would be 20. You take half of that, 10. And then, even if you're just trying to do this in your head, 15 times 12 is a little tough to do in my head. I do 15 times 10, that's 150, and then 2 times 15 is 30. 150 and 30 is 180, because then multiplying that by 10, I just add a 0. And then I get 1800. 180, add a 0 is 1800. Either way, there's some little tricks for you on multiplying in your head and multiplying numbers. Oh, and there you go. There's my first mistake. I forgot a 0. See, look over there. 1800. Well, lucky me, because now on the spot I get new numbers and I get to demonstrate again. Oh, sad. I don't have 20 this time, so it's not easy to do, but I could half this 18 into 9 and do 9 times 11 is 99. 99 times 15. Ooh. Well, what's 100 times 15? That's 1500, and if I need to do 99, I just subtract 15, one less than 1500 is 1485. All right, let's see if I can flex right now and just do this in my head. Ooh, got it. There you go. There you go. Every mistake is a teaching moment, just like that one. Got to demonstrate on the spot. All right, finally, this problem's a little fishy on number 8. Get it? Fish. It has to do with fish. All right, a fish aquarium has a length of 120 centimeters, a width of 70 centimeters, and a height of 50 centimeters. Each fish, I need to take a drink of water. I'm talking too much. Requires 3,300 cubic centimeters. That means same thing as centimeters to the third power of water. What is the maximum number of fish that a tank should hold? There's that water. All right. It only seems fitting that I'm drinking water, given that this is also talking about water. This is a problem every year that I always say the words, I don't care about decapitated fish. I do not care about decapitated fish. I mean, in general, I care, I guess, about all animals and all fish. But for the sake of this problem, I do not care about decapitated fish. I only care about the whole ones, meaning you're going to get some decimal. Don't care about the decimal. Just care about the whole number of fish. You could shove part of a fish technically in this tank. Let's not worry about the part. Well, this is a rectangular prism. If you think about a fish tank, most of them, like this one, are going to be boxes, rectangular prisms. And we know from our formula of a box that we need to multiply the length, and the length again is 120, times the width times the height. So 120 times 70 times 50. And that tank has a total of 420,000 cubic centimeters worth of space, but each fish needs 3,300. So I then could take that number, 420,000, and I could divide it by how much each fish needs. And you could see that I get 127 fish and then this decimal of a decapitated fish. We do not care about you, decimal. We only care about whole number of 127 fish. And hopefully I didn't make 2 mistakes in a row. I did not. It's good to know that your teacher is human, but again, that mistake was such a valuable reteaching opportunity. As always, I will submit this assignment to see that beautiful 100%. You see I filmed this on April 15th. That's tax day. At least it would be normally, but we have that 3-month extension this year. Oh, what a time we're living in. All right. Hopefully that made sense. Reminder, you also have the notes in PowerPoint. I know some of you guys are contacting me that for whatever reason YouTube's blocked for you, so you might not access this video, but instead you'll access the PowerPoint. That has worked as well, making sure you have every resource away from home right now. All right, that was volume, and I hope the volume of the rest of your day is as spacious as a 3-dimensional box. This has been your teacher Dylan delivering class away from class. Have an absolutely wonderful day and take care.